Well, good morning, everyone. Sorry for the hiccups. Yes, that's normal. Thank you for coming on Saturday morning to learn about new technologies. Very exciting to see such a full room. I'm Eva. I'm head of Rakuten Institute of Technology Singapore, and our team has been working on developing online language learning tools on top of Rakuten's digital media content. So what we're doing, we're taking the entertainment and combining it with education. And today we will show you a behind-the-scenes look into what we do and how we do this. So I will start with our journey. I myself am from Poland. My team members, Stanley and Liling, are from Singapore. Pang is from China. So together we know 10 different languages in varying degrees of fluency. But through this experience of learning all these languages, we independently arrived at a conclusion that really, the textbooks and classrooms and doing vocabulary exercises can really take you only so far. To really learn the language, you need to immerse yourself in the language. And the best way to do this, obviously, is to just go to a different country and practice the language. But it's not always practical, not even possible to just set off to another country to learn that language. So instead, there is an alternative that worked for us, which is watching authentic content. And this recreates to a certain extent the immersive environment that allows you to soak in the language, especially if this is the content that you are really interested in. Well, it turns out that we're not the only ones that came with this brilliant idea. In fact, millions of people all over the world do it. 30% of Rakuten Wiki users are actually learning languages by watching Wiki content. For those that haven't heard about Rakuten Wiki before, it is a service, video streaming service that specializes in streaming Asian dramas, Korean, Chinese, Japanese to Western audiences, especially in Americas and Europe. And they have a community that's very passionate about Asian culture and languages. So they watch those dramas, they supplement their language learning by watching, but they don't really have tools that would make it easier for them. So it's still a very manual process. They have to pause, rewind, listen over and over again, jot down things down in their notebooks. It's really old school. So we thought, okay, is there anything that we can do to make this process of learning with entertaining content easier and even more engaging? And there's a lot of things that we can actually do. So imagine that you can take any content, be that audio, video, text, and then automatically convert it into language learning material, and then put language learning tools on top of that content. So that's something that we got excited about, and it can also help a lot of people worldwide. There is, at Rakuten, we're uniquely positioned to actually offer this type of solution. Rakuten has a lot of great content. We have users worldwide, and we also have a technology that allows us to develop those type of solutions. And we can help a lot of people in the process. There's 1.8 billion people studying foreign languages worldwide. And still, language learning is mostly offline. So 95% of the market is still traditional classroom, textbook, paper-based dictionaries. But the trend is shifting very rapidly, and right now digital language learning is the fastest growing segment of the $56 billion language learning market overall, and it is set to reach over $4 billion by 2020. So, with all of this, with our vision and the purpose that we have in empowering language learners worldwide, we develop 3 products that each of them took us between 1 and 3 months. They're separate, we've launched them. We have interactive subtitles, we have video dictionary, we have quizzes, And they're separate, but to help you envision or to help illustrate how we envision this language learning experience to look like, we stitched them together in this demo video that I'm going to play to you right now. Let's see if it works. Of course it doesn't. Let me just look for it quickly. Okay. Okay. Anyone here that can help me? I don't really. Yeah, anyone can tell me why I'm not. Oh, I see the mouse there. So you just have to click play. And start from the beginning. Just go to the beginning. My precious minutes. Okay, anyway, so users watching their favorite content, Chinese drama in this case, they're navigating to the segment they're interested in, they're clicking on the word they want to learn. Then not only do they get definition of that word in that single drama, but we're pulling a lot of different scenes where you can see that word being used in different contexts, in different accents and motions. User can save this for later practice, and then they can take quizzes. They're dynamic, they're adaptive, they're fully personalized, so they can practice the vocabulary, assess their knowledge, track their progress over time, see how they did, see how they compare with others, and then they get recommendations for vocabulary and videos to learn next. Okay, so okay, great, I'm back. So with that, we had quite a bit of initial success with these 3 separate products. The first one, and now it's all gone. Okay, well, once somebody help me get it up and running. So the interactive subtitles is something that we launched in collaboration with Vicky. It's called Learn Mode. And we got over 30,000 users using it every day, so daily active users. Very high satisfaction, high engagement. People that use Learn Mode watch on average over 10% more content than people that don't use Learn Mode. And a lot of good positive feedback on social media and the press. If you are in Japan, unfortunately, you cannot learn Korean with the content. I always get this question, but you can learn Chinese with Return of Happiness or Daughter Back and other popular Chinese shows. Mostly Learn Mode is limited by the geographical restrictions of the licensing. But if you're in the US, you can learn Korean with the hit shows like Descendants of the Sun or Boys Over Flowers. It's on PC right now, so we don't have a mobile version yet. Another product that we launched was a drama vocab quiz that was taken over 60,000 times, but over 35,000 users. Again, with a very positive feedback. And this one is for you to test knowledge of Korean or Chinese. And you can take it wherever you are in the world. So I encourage you to go to this link and see how good you are in Korean or Chinese drama vocabulary. And then finally, the video-based dictionary. This is something that we have a closed beta trial with the universities. So we're trying to integrate this with the university curriculum to support students in learning the vocabulary that they have to prepare for their tests and exams. And then let me just share this quote with you by Nelson Mandela, and I'll paraphrase. So if you talk to people in language that they understand, it goes to their head. But if you talk to them in their language, it goes to their heart. So in a sense, we're not only developing technology that helps connect people, but also, or help communicate, but develop this deeper connection between people. So this really nicely illustrates also the theme of today's conference, so heart, head, and hands. Heart, we really want to understand the users, and then we care about developing solutions that work for them. We leverage the latest research to develop the solutions, and then hence we apply engineering principles to develop solution at scale to users. So I share with you why we do what we do. Next, Liling and Stanley are going to share about the research part, and finally Pang is going to show you the engineering platform behind our language learning tools. So that, Liling, wanna take that? Just go down.
So hi, I'm Liling. I'm from RIT Singapore, working with Eva, Stanley, and Pang. And just now you saw briefly what is the drama vocab quiz, and I'm going to tell you how we build it and some of the core technology that use AI and NLP, which is natural language processing, to power the quiz. So I'm a linguist by training, so I really like language, and that's why I thought the first question you ask when you're learning language, how many words do I know? But the question should be, what is a word? So what I'll be going through is the introduction, the demo, and then we'll have some introduction of how it is. One thing that happens is we always ask ourselves why we take quizzes, because they're fun, they could be viral, we see people sharing them. And also, creating these quizzes are tedious, you have to manually create them. Teachers kind of sit down and say, oh, this is the right word, this is the wrong word. After thinking about the right word and the wrong words, you must also give the wrong answer so that there's multiple choice for the quiz. So we created this that will generate the quiz automatically. We have two versions of the quiz, one in Korean and one in Chinese. We took the Korean words, and then what we did is we see the Korean word up there with the romanization, the language speaking, that you can hear the sound, and then we created the answers, as well as we generated the distractors, which is the wrong answers, so that you can have this kind of multiple choice. For this, you see that the word is Zhonghua, which means telephone. It sounds like Chinese, Tianhua. And then the next, this is another example. This is Nangman, which means romance. It also sounds like Chinese, so Korean, Chinese, and Japanese are kind of related. And at the end, we show this very fun results that says Hyo, which is like a K-pop word to say, oh my god. And then you know how many percentage of the words. And the magic comes in estimating how many percentage, as well as knowing the different words that we have. So we see here there's easy, medium, and hard. We actually split the words automatically into 3 different difficulty, and I'll explain later why we split and how we split them. So the more interesting part of the quiz is after taking the quiz, when you have a wrong answers, it will point you to the word and the video that contains the word. And once you click it, you'll go to the motion dictionary, which you see just now, and Pang will describe it later, more about that. And you will see that you can learn more about the words, save the words, and maybe perhaps take the quiz again to know whether you have learned the word. So how did we generate the quiz automatically? First, as I said, we must know what is a word. We took the corpus, which is text that you see for the Korean dramas, you have the caption and the subtitle. We split the Korean sentences into words, which is individual tokens. So in this sentence, it's Minam Isa Laguyo, which means someone said he is a handsome guy. You can see Korean is jumping up all the way. But in a normal sentence, this will have been one word, and this is one full sentence. So what we did is we only keep the Minam, which is the root word itself, and this in linguistics is called a lemma. and we count this as a unique word. So this will be the vocabulary that you want to learn when you study Korean, the first few. So after creating the corpus, which is the text, and then the tokenization is to split the words, split the sentence into words, we actually have to throw out a lot of rare words that are not very helpful to beginners learners. So these are words like power transmission, lymph nodes, deprecation. This comes from, like, you can see some of these terms are technical terms coming from medical and scientific kind of terminology because of the drama and what they say. Then the last part, we translate the words using our in-house dictionary. Rakuten have a big source of data. So this dictionary, Stanley will be briefly talking about that later. And the last thing that is to improve the user experience, we filter out the swear words. We don't want users to kind of get stunned and learn swear words in the other language. Yes, you must speak to the heart. Yes. And the last thing is, we see from the results page, we split them into 3 parts. So at the end, we had 6,000 Chinese words after the filter, 4,000 common Korean words after the filter. We split them according to how many times they occur in the text. So of all the subtitles that we have, we counted how many times the word occurred, and then we say that the 0 to 25%, we say is an easy word, which means the highest frequency is an easy word. 25 to 75% is a medium word, and anything beyond 75 to 100% of the full frequency, that's the hard word. So for each quiz, we will have 30 questions, 10 words coming from each bin. The last magical step is to create the wrong answers. How do we create the wrong answers? This is where AI comes in, and this is where the latest technology in converting word into vectors. If you want to know more about this, you can come talk to me later, because this will be a technical issue that will take 1 year or maybe 1 hour to explain if I'm good enough. What we did is we had the word man. We want to generate the first distracted as the wrong answer. We will find the 5th to the 20th closest word using this cosine function that will calculate the similarity between the two words. Why we use the 5th to the 20th is because the 1st to the 4th might be the same word itself. So you have things like, if it's a man, you could have said that it's an adult male, and that will be the same word, and it will normally occur in the first 2 similar words. That's why we choose the 5th to the 20th. Then later, using another function called cosmil, this is interesting because the first one only measures similarity, the second one measures similarity and dissimilarity. So we use the first word as the seed to find the similar word, and the second word as the negative example to find the not similar word. And from the word vector model itself, it creates the last word, which is Sunday. And from here we see that this is cool because now you have 3 things that are somewhat related but not related. So when the learner takes the quiz, they wouldn't have this thing that, they wouldn't have this thought that it's too easy, I can just see the answer directly, or it's too hard because all the words have the same answers and they are very complicated. Yeah, as we see just now, there's 60,000, 35,000 users who took the quiz, and actually 16% of the users took the quiz again and again. There was one person that took it like 60 over times, which is very interesting. So one thing that we used was the word frequency. We counted how many times a word occurs, and we used that as an indicator of difficulty. From the statistics that we get from how many people take the quiz and how well they fare for the quiz, we see that for the it doesn't show. Okay, pushing the screen back doesn't work also. Anyway, so the blue one is the easy, and the green one is the medium, the red one is the hard. For these 3 different ranges, we see that the average number of correct answers for the easy bin is 8. The average for the medium bin is 5, and the average for the hard bin is 4. We see this decreasing trend because we say that frequency is a good proxy, and it is, because if not, you have scored 10 for the hard words. And to conclude, you should watch more drama and learn language. So for more detailed information, you can go to the tech blog that we'll discuss more about this. Thank you.
Tell them that
that worry that you're going to find out more different stuff.
Hello, I'm Pan. I'm the engineer and architect of the team. So my presentation is mostly going to be the engineering portion of the language tool. And I will cover two topics. One is the motion dictionary or the video dictionary, whatever you call it, and how it was built. And then secondly is in general, when we are building this whole things for the past 6-8 months, how we iterated fast enough to test out multiple versions of it and get feedbacks and come back and change it again. Right, so firstly, I'm going to show you some quick demos of the dictionary. Right, so let's say you want to search a word. Too fast. Let's say you want to search a word. In this case, maybe father, and you will get a kind of a dictionary output of it, which contains the pronunciations, the meanings, and also a list of sentences. So the list of sentences contains scenes from multiple sources, multiple videos, where the words is being pronounced and used by different actors. So here is a lady talking about his father, and this is another lady talking about his father. This is not sure who. So this is another man, or yes, another lady. Okay, this is finally a female. So you can see it's coming from different scenes and also different shows. The purpose of this is that if you look at traditional dictionaries, you also get some kind of sample sentences. Some of them also come with the voice, but they're very genetic. A robot voice, or even if you have a good text-to-speech system, it's still kind of like a genetic voice. But right here, you get the actual scene of actual actors or actress speaking in the real scenarios. So some of them is yelling, some of them being sad. So the different tones and the way to pronounce it in real life, you get to experience that. It will be very grateful for someone who's learning a foreign language as well as the foreign culture. Yeah, and also some nice features will slow down because you find out that people will be very difficult to catch up some of the real people speaking as a native speaker. And also the sort of normalization portion, which is pinyin in Chinese. Yeah, right, so that's basically all the features that we have. Right, so you can see it's kind of like a basic search functions, and but instead of searching in a common search that you know as the web search, we are calling it an individual search. So what we have as individual search is actually very similar concept as the web search. Instead of pages that you have for web search engines, you call pages. Right here we are pouring clips. So the clips are from the videos, but there are small pieces of them. It really depends on the video source you have. In our cases, we are now getting the video from Rakuten Wikis, where they are already cutting the videos by 5-minute segments. We calling that as one case, and another case is that we are following through the sentence, the spoken sentence, and the subtitles timestamp to split them into different segments. And if in more depth, if we want to compare how this individual search is done, we can basically align it with a traditional web search, which is to collect firstly the metadata of the objects, which is in the video case is like the metadata of the video and the metadata of the clips, like the timestamp and how long is the length and what's the format of the videos. And then for the relevancy of searching the clips, so compared to the web where you are crawling the words and the image of the page, for clips you can just simply pick whatever you can find within it. So if there are subtitles, you get the subtitles. If there are translation of the subtitles, another translation of another language, you take it, you get frame by frame of the clips and you get the audio. So whatever that you can help to to see if it's relevant to the word that people are searching. And the biggest difference is that for the last part, for the ranking. So as we all know that if you're searching something on Google or Bing to find something, the returns, the selection of the return content is focusing on the quality. So how good is the web page, how good is the website. But for the in-video search, the dictionary we are trying to make it available for the learners. So for learners, you don't want to return a bunch of sentences that are too complicated, that are too long. They contain maybe 20 seconds spoken dialogues, which is like 50 different words, and the words that they are searching is part of it. It will be too hard for them to learn the word itself. And you don't want it to be all being a very similar sentence. So it will help sometimes, like maybe you can hear that multiple people pronouncing the same sentence. But in this particular case, especially a lot of words have very different meanings, used in different contexts. So you want your selections to be more diverse, so you can cover every single meanings with some of the clips, so that the diversity of the full selections is also one of the ranking criteria. So there's a lot of things to twist around here, because there's no standard so far. We haven't seen any other companies or communities doing this kind of works, so we couldn't even have a place to talk to people like, how do you do that, how do you do that? Let's share some experience. So if there's anyone who's doing that or planning to do that, we actually very welcome some discussions so that we can explore what are the other ways to build this kind of things. So this is one of the motion dictionary, and then next is going to be in general how we build the whole things. Actually, it's every single thing, because at the very early times when we are planning to develop language learnings, we already know that we are going to do it fast and do it quickly, and we will definitely have something that will only prove the concept at the beginnings and throw away, and we will replace it with something we build in-house. So that's why at the very beginning we have decided to follow the microservice architectures. Is kind of a design principles for building systems that could be more agile and fast to deploy. The basic concept of microservice architecture is there are a lot of books outside, so I won't be explaining from scratch. But in general, you are basically you can just take it as do one job at a time and solve one problems with one independent block of applications or components, we call it. So I will show you two examples that is actually used in our systems. So the first one, let's imagine that a case where you need to prepare some data for consumption. So for examples that when we are preparing the dictionaries, we need to take in some of the data, the video data, the clips from Rakuten Wiki, and we need to prepare it so that our search function can consume it. So in order to build these components, we need to answer some of the questions. So for example, how does the data come from? So in our real cases, we have batch of data, like big batches of videos coming through the wiki, and also we have the view times, because there was some kind of a real time updating system from our content providers. So we provide two kind of interface, which is FTP and as well as the API to solve to handle the in batch processing and the real time processing. And then secondly, let's say, well, what needs to be done for it to be ready? So most of the time, but not all the times, it needs to be cleaned up. But some of them that do not have to be cleaned up at a very fast pace, but some of them needs to. So we will have some triggering functions and pre-processing functions to take care of that. And the last one is how the data will be consumed. In our particular cases, it's only ad hoc internally. It's because it will be triggered by our own functions. So we don't need to have a lot of authentications or any of the other layers, simply a data accessing functions. And next one is how we're going to give it to other people to use. So it's like individual functions as a components. In this case, that we are facing the external user, sort of the web or the public. Now we have to take care of the repeatedly access, and then also maybe at peak traffic, because we have marketing departments doing the push. in this case, we are preparing the API endpoints as well as a cache to store and fast the repeat calls, as well as a queue to take care of if there's a peak traffic, we can balance the load. And at the back ends, you notice that the application logic could be calling some kind of internal or external service to help its logic. So if you have a cache, you will be able to bring it together and also make the process faster. And I'll quickly show you through this kind of building blocks in real scenarios. So in the motion detection, we are building different blocks for different video providers, so that the pre-processing of those from Wiki or in the future Rakuten TV and other third-party videos, it can be done all separately. And for interactive subtitle, which is going to be presented by Stanley later, it's also kind of a similar process where there are multiple blocks of multiple data being prepared at the beginning as from open sources. We replace it with our in-house solutions one at a time to test the qualities. And at the end of this, we will replace all of them with our one global solutions that was built completely by ourselves. And the last one is the vocab quiz. It's once again, since we're already using the wiki data, we can generate the quiz contents and host it separately. And once the front ends only need to consume the contents regardless of where it's coming from. And there's very nice features that we did is that we have one extra functions that we add after the first round of feedback, which is the voice, giving the pronunciations. We did not have that at the beginning, but we got a feedback which is really needed for a lot of language quiz takers, that they believe if they hear the sounds, they can guess the word much better. So it really shows you that this kind of architecture is giving you the flexibility to keep on adding things and changing things in a very fast pace. And to conclude that, this is a quote that Ella asked me to make a quote at the end. So fast iteration won't be possible if there are many things. I hope Martin Flower or whoever haven't said that before, so check that as well. Okay, so that's it for me. So let's pass it to Stanley.
So as Stanley is setting up, I think we can just do a quick Q&A. Maybe a couple questions to Liling Pang. Anything you guys heard so far? Okay, there's a question there.
How do you choose which dramas would you use for your product? Because I think your selection of dramas would dictate other things such as filtering, which are the rare words and the likes.
Yes, no, that's an excellent question. Right now, we let users choose from which dramas they want to learn. So we make it completely flexible for the interactive subtitles. For the quiz, you're right. So we have some flexibility. Right now, we're including all of the words from all of the dramas. But we could, you could argue that maybe historical dramas couldn't be included, or there should be a quiz, only from medical dramas. Or you could also allow learner to just quiz themselves on their favorite drama, right? So the vocabulary. So there's quite a bit of flexibility, and the infrastructure that Liling and Tang propose, they can handle that. So we can design it any way we want. Thank you.
The way I understand it, you're using your subtitle corpus basically to generate all of your data. Have you attempted like some sort of automated tagging system, or just automated systems to pick up these words?
So maybe I can answer that. There's no annotation involved, so there's no labels or need to create anything. So you can see that it's pure counting, and the word-to-text model doesn't need any annotation by itself. It just needs sentences that are sound and logical. So actually, if you just dump in another set of body of text into the system, it will create a quiz based on that text. So it could have been subtitles, it could have been storybooks. Kobo can use this, or any other any other companies that have a large, huge text can generate quiz automatically. So yeah.
Well, just let Stanley present one more presentation, and then we can take a couple more questions.
Yep. Sorry for the hiccups. My fault. I forgot to worship the presentation gods today. I'm Stanley. So Eva has gone through the overview of our system. Li-Ling has given you more insights into one of the components, the quiz, and Pang has given you a view of how we actually lay out our architecture. Right now, I'll provide more texture to two more components, namely tokenization and dictionary induction, and show how we develop them quickly in a matter of a few weeks. So what's tokenization? Tokenization refers to the splitting of a sentence into its constituent pieces such that each piece retains its original meaning. Now, unlike English, Asian languages like Chinese and Korean do not rely on spaces to separate the words. So here I provide a tongue-in-cheek running example that I vaguely recall seeing in the Chinese romantic comedy, 你是辣妹也是名门贵族. At the bottom, I give you the correct translation, the correct tokenization, which translates to you are a hot chick and of the gentry, and also of the gentry. At the top, I show you a wrong tokenization. And it's wrong because the second last token corresponds to gibberish, just meaningless. So some of you might be wondering at this point that tokenization can simply be accomplished by making sure that every single piece is meaningful. But tokenization in many instances is more nuanced than that. So here's one example. 努力的人才会成功. Here I show you two different tokenizations. Both are correct and they differ only in the green parts, right? With the first tokenization, the sentence translates to only hardworking people will succeed. Now this gives all of us hope that as long as we work hard, we will succeed. With the second tokenization, the sentence translates to hardworking talent will succeed. So this means that in addition to hard work, you really need talent. So this shows how different tokenization, both of which are correct, can lead to very drastic differences in meanings. So it is a challenging problem. So how do we use tokenization in our language learning platform Learn Mode? Here I show you a screenshot of a Chinese video with dual subtitles in Chinese and English. So under the hood, we tokenize the Chinese subtitles, and this allows the user to pick up any piece that he or she is interested in finding out more about. So let's say that he picked the Chinese piece. Then with this Chinese piece here, we could actually take it to our dictionary that I'll talk more about later, and fetch relevant information about it, such as its meaning, pronunciation, among other things. So when we first started developing our language learning platform, we observed that there were many free, open source tokenizers available for Chinese and Korean. So rather than reinventing the wheel and to expedite our development so as to get our product quickly, we decided to use open source tokenizers. However, upon experimenting with these tokenizers, we found that though good, they're not perfect. They do make mistakes, but they err in different ways. So this begs the question, can we actually do better by combining the tokenizers such that the strengths of one could actually be used to overcome the shortcomings of another? Before talking about our solution proper, we have to first define what we mean by the goodness of a tokenization. To know whether one tokenizer is better than another, or the combination of all of them performs the best, we need to define what's good, what's a good tokenization. So here, we simply take a human learner's perspective and heuristically define the goodness of a tokenization as the number of dictionary lookups that are required to understand all the tokens. And in addition, we make the assumption that if a token does not exist in a dictionary, then it requires a large number of lookups, which we heuristically set to 10. Now, the lower the number of lookups, the lower the cost, the better the tokenization. We are aware that there are other metrics that we could have used, such as perplexity, frequently used in language modeling. But to get things going quickly, this is what we did. And empirically, we observed that this works very well. So let me illustrate to you this particular measure that we adopted. So at the bottom here, you see 3 different tokenization of a phrase, 你是辣妹, with the leftmost ones being correct. So the leftmost tokenization breaks up the sentence, the phrase, into 3 parts, all of which exist in a dictionary, in our dictionary. So therefore, its cost is 1 plus 1 plus 1 equals 3. The second tokenization is not quite correct. Break it up into 4 parts, getting a cost of 4. And finally, the last tokenization is totally wrong. We broke it up into 3 parts, but the center part is gibberish, thereby getting a cost of 10. So 1 plus 10 plus 1 equals to 12. So this is how we cost our tokenization. Now, with this tokenization in hand, some of you might be thinking, hey, the solution is simple. Just pick the lowest cost tokenization across your group of tokenizers. Simple solution. But we can actually do better than that. We can do better by creating a new tokenization that is not returned by any of the tokenizers. We can do so by identifying tokens that are common across all tokenization, use those as anchor points, and then pick the best tokens from the remaining ones. Now, what I've said sounds rather abstract, so let me illustrate it. So here I show you 2 tokenization of a running example, both of which contain some error. So in parentheses, you see the cost of the tokenization. So the top tokenization made an error over here. This is gibberish. And the bottom tokenization made an error over here. So this is our final correct tokenization. So observe that both of these tokenization that we got from our open source tokenizers, we have the green parts that are the same. So we call these anchor points, which we retain. Then from the remaining parts, we pick the tokenization that has a lower cost. So in this case, from over here, we pick a tokenization from the top. And over here, we pick from tokenization from the bottom, thereby getting a better tokenization, one that performs better than our original tokenization. And this has a cost of 5. Okay. So I've covered the component on tokenization. So now let's move on to the second part, bilingual dictionary induction. Now if I'm going to speed up a little bit more. So if you have learned a second language, you'll know that bilingual dictionaries are very important for language learning. One way that you can get dictionaries to define this manually. But clearly this is not scalable, even though it gives you a very high precision, high quality dictionary. There are about 7,000 languages in the world. Therefore about 49 million bilingual dictionaries out there that you can get possibly. And if you're going to do it manually, well, that's not going to cut it, right? It's not going to scale. So we need an automatic approach. So we take a first step, just a first step. We take a first step towards this approach. And how we do it is by first observing there are lots of online bilingual dictionary out there. The question that we ask is, can we actually learn new dictionaries from what we have on the web? For now, we're focusing on Chinese English and Korean English bilingual dictionaries. Like I said, there are lots of dictionaries online, but only some of them are Chinese English and Korean English, many aren't. However, there are managed dictionaries that go from Chinese to intermediate language, from intermediate language X to English. So this X language could actually be used as a bridge. So for example, we could have a Chinese-French dictionary and a French-English dictionary. So let's say that in the Chinese-French dictionary, we have la mei being mapped to feel sexy, a French phrase. And from the French-English dictionary, that takes you from feel sexy to hot chick. Thereby, by taking 2 hops, 1, 2, we actually get the correct mapping from Chinese to English or Chinese la mei to English hot chick. So for now, this is what we did. We are taking 2 hops for now. You can imagine taking more hops. The more hops you take, you increase recall, you're getting more entries but reduce precision, right? So with this approach, we got about 750,000 entries in our Chinese English dictionaries. Manually sampling them, we found them to be 90% correct. For Korean English, the corresponding number are 100,000 entries, about 99% correct. So all I've described is really still early days. So what we really want to do is to induce bilingual dictionaries using what I've just described, the dictionary terms created as seed lexicons, seed dictionaries. So using these seed dictionaries, we could actually induce a vector space in which bilingual phrases with the same meaning are mapped onto common points, and jointly project monolingual data, which is plentiful, onto the same space, thereby inducing more bilingual pairings. Okay, this is what we are after ultimately. This is still work in progress. So far I've described to you two critical components of our system, tokenization and dictionary induction. And with that, we're happy to take more questions. For anyone. Yeah, right at the back.
So, two questions. The first one is, I'm curious to know what kind of tokenization package you use. And the second one is, like, I'm very curious, what's your plan on like calculating the similarity of the sentences instead of the word, because vector space uses word similarity now, but what's your plan for calculating sentences?
Right. So the first question, the package that we use for Chinese, we use Jieba and as well as Stanford tokenizer trained on PDB and CKB. So there are two different tokenizers. For Korean, we use KKMA, Kumoran, and one more that I can't recall off the top of my head. So it is definitely more than two. As for how we want to approach this, so we are still looking at pretty much word and phrases level, words to phrases to VAC level, like what Li-Ling has described. As for sentences, well, you have sentence to VAC, which is already out there. But we're definitely not looking at that right now because we still, but for this task, that is not relevant. But for the task of actually creating translations, yes, that would definitely come into play for the dual subtitles. More questions? For me, Li-Ling, Pang, or ever.
What other cool things do you do?
No, not from you, come on.
Okay, so just as you mentioned, there's a case that you have different kinds of tokenization, but both or all of them are good. Like 只有努力的人才会成功, for example. So what will you decide to choose which one in different conversation or environment?
Yeah, good point. Good observation. I did not say how we choose. It's still work in progress, but the way we choose is because we are blessed. We are blessed with having dual subtitles. We are blessed with having the English translations of the Chinese. So the key here is to use English translations as a constraint to force the tokenization to fit the meaning of the English one.
Does that mean you have machine translation behind?
Yes, we have machine translation behind. Yes, we're working on it. That's right. Now the secret's out the back. More questions? Why did my presentation not get loaded? Okay, just kidding. Forever, Pang, Li-Ling. If not, thank you very much.
Thank you very much, and we'll be at the conference throughout. So if you want to chat to any of us, Li-Ling, Pang, Stanley, myself, let us know. So thank you so much for your time.